And so this is actually showing up on the worksheet today. You work that out.
So P B given A is P A and B over P of A.
B given A, yes.
Okay.
Yes. And you guys should also know how these formulas change when A and B are independent or mutually exclusive. So for independence, and you can't assume independence unless they explicitly tell you. Okay, so probability of A complement remains the same. The only two ones that change are the bottom two and the AND probability. So probability of A and B. Now intuitively, this is what most of you would want to do when there is an independence, is just multiply the individual probabilities. But only when there's independence can you do that. So probability of A and B when independent equals probability of A times probability of B. When it's mutually exclusive, probability of A and B is what? Does anyone know this? When mutually exclusive. Hmm? Are you adding them? Subtracting? It's 0, right? This is an important concept. Yes. This is important for the derivation of the next two. So probability of A or B, this is the same, use the same general formula. So probability of A plus probability of B minus probability of A and B. Now since we said A and B are independent, this becomes just the product, probability of A times probability of B. And that's the only modification there. Similarly here,
Can you go over that again?
okay, so the general form for an OR probability is the probability of the first plus probability of the second minus the intersection probability, right? And it turns out the intersection probability when independent becomes just the product of the individual ones. So you just substitute that in. Yeah. And here, the same thing, the individual probabilities, but remember, now this intersection is 0, so you just drop it off. So this is just probability of A plus probability of B. This third one, the conditional one, probability of A given B. Does anyone know what that is? When A and B are independent, what is the probability of A given B? Just probability of A, right? Because B does not change the probability of A. Now, what's the probability of A given B when they're mutually exclusive?
Is that what you got?
Okay, so what is this? This is A and B divided by B, right? But in the mutually exclusive world, something funky happens with A and B, right? Becomes 0. Yeah? Make sense? So there's 3 different sets of formula that all stem from, or in certain conditions change. So these 3 are all different. So know what happens when they're independent, when they're mutually exclusive. And this is really the key for when it's mutually exclusive, this part. Because here we omitted this part because of this. Here, this is 0 because of this. So this is the key, the AND probabilities. Here, the and changed. Here, the and would change too, and they would cancel. So the and probabilities are the only ones that are really affected by independence and mutually exclusivity. But the rest of the formulas are then dependent on the and probabilities. Are there any questions? Yeah?
Yeah, what about when they're not either independent or?
Okay, so when they're not, when it doesn't say anything, you use the general ones. These ones. Anything else?
Do you know how the tests are going to be structured?
They're kind of running 5A a little bit differently this year, or this quarter. Generally, it was 5 exams an exam every 2 weeks. But now this is 3 weeks and then an exam. So I'm assuming you're going to have about 7 questions. You have a 50-minute lecture, right?
Yeah.
So you're going to have 50 minutes to do that. Focus on main concept.
I mean, the questions on the worksheets?
Yeah, it's going to be based on this stuff. Any other questions? Yeah.
If it doesn't say mutually exclusive or independent, can we sometimes assume that it's mutually exclusive or independent, or do we have to wait till they say it?
It has to explicitly say it.
Well, like, so if it's a flip of a coin, we can't assume that.
Well, if it's a flip of a coin, you can't assume anything. Now, if it says a fair coin, then you can assume each flip is independent of the next flip.
Is there any other keywords that would take you off to things like independent? Because in that situation, they wouldn't say it.
So mutually exclusive means they can't occur at the same time. So maybe if it's written that way, you can assume that. Or if they say the probability of one does not affect the probability of another, then you can assume independence. Yeah.
Just to ask her, if we don't know, can we test what if it's independent or mutually?
You can test. Okay, so to test independence, to test an independence, this is what you're going to use. So you're either going to be given probability of A, probability of B, or ways of calculating these 3 pieces, and you just multiply the 2 individual probabilities and see if they equal the intersection probabilities. Yep. And for this one, we'll
Use out.
Just a question about the quiz. Is it okay we put because sometimes we get answers in fractions. Is it okay we leave them as like decimal?
yeah, that should be fine.
What exactly is mutually exclusive?
It means A and B cannot occur at the same time. So you can't get an A and a B in a class. Right? So those 2 events are mutually exclusive. It means they can occur at the same time. It's just if one occurs, it doesn't mean the other one can't. Yeah.
Okay.
Anything else? All right, let's get a little bit. So that's all you're going to need for the worksheet today. So there's just 6 questions. Working groups if you'd like. That's about it. I'll be walking around for you guys. And if you have blue books, turn them in with your worksheet.
Is it a big deal if you don't simplify fractions? Or?
I would like it to be in 1 fraction, but you don't need to simplify.
So we can use those things with calculator.
Yeah, you can. Just as long as you can't store any information on them.
So graphic calculator and the next one is
Generally, no. Yeah.
like when they can do graphic.